Bismillahirrahmanirrahim and Assalamu alaikum. How are you students? Hope you are doing well. Today we are going to study a new topic. It is dipole moment. Okay, let's study what's dipole moment. First of all, before studying dipole moment, we should know what is the polar bond or how a molecule becomes a polar. If a molecule contains polar bonds that are unevenly distributed about the center of that molecule, then there will be an uneven charge distribution across the entire molecule, making it a polar molecule. For example, let's see a water molecule. You can see in this part there are two electrons over here and two electrons over here. This part is oxygen. We know that oxygen is more electronegative. It is more electronegative, and for hydrogen we know that it is less electronegative. Okay, it's the kind it's 2.1 and also 2.1, and this was 3.5 for the electronegativity of oxygen. So we know that these two bonding pairs are polar bonds. Why? Because the electron cloud is concentrated upon the oxygen. The bond is still covalent. It is not an ionic bond, but it's a polar covalent bond. So that's why when both bonds are polar, and we also have some lone pairs in this part, in this case this molecule is a polar molecule, and polar molecule has a dipole moment. So what's dipole moment? Dipole moment simply measures the net polarity in a molecule. Dipole moment says us whether a molecule is a polar or non-polar. Yes. Dipole moment is due to the separation of negative and positive charge. Over here we have the formula or equation for dipole moment. It is mu. Okay, it is mu. It is the symbol for the dipole moment, and q. Q is a symbol for charge, and d for the distance, or d for the distance. And guys, remember that dipole moment will also be a vector quantity. And how we show this vector, how we show this arrow? The head of the arrow will be towards the negative end. The tail of the arrow will be towards the positive end. Always, if a molecule is a polar molecule and it has a dipole moment, we will show with this kind of arrow, and the head of the arrow will be at the negative end, and tail of the arrow will be at the positive end. You must remember this. And the next thing is that to there be a dipole moment, the molecule must have some one or more than one polar bonds, and the next thing is, or it can have lone electron pairs to have a dipole moment in a molecule. Okay, let's work upon an example whether this molecule is a polar or non-polar. The very easy way to know that if a molecule is polar or non-polar, we have studied in the non-polar covalent bonding. We know that the electronegativity of fluorine is, for electronegativity of hydrogen, is 2.1. The difference is 1.9. Okay, this means that it's a polar molecule, so it has a dipole moment. But there's something else. Dipole moment has a kind of unit. Its unit is known as dBi. 1 dBi is equal to 3.336 times 10 to the power of minus 30 coulomb times meter. Okay, so let's work upon the dipole moment of this diatomic molecule with the help of that equation. We remember the equation. It was kind of mu is equal to q times d. But there's something else, student. In a polar covalent bonding, inside the molecule, the atoms are not totally positive or negative. There will be some partial negative and positive charge. For example, in this case, in this one, let me erase it. Over here, the hydrogen has a partially positive charge, and it will have a partially negative charge. So electron cloud is concentrated more upon the hydrogen rather than the more upon the fluorine rather than the hydrogen. And if you want to show the dipole moment of with the vector, we can show something like this. We know that this is a one polar bond, and the electronegativity difference is very high. So in this case, it's a polar molecule, and it is a dipole moment. And if we want to find this dipole moment in the units of dBi, now we can use it. Mu is equal to q times d. But as I've told you that They don't have total positive and negative charge. They have some kind of partial positive and partial negative charge. So the partial positive or negative charge, the charge difference will be kind of 0.41. Okay, so in this case we have to make a little bit change in our equation. We have to write it like this: mu is equal to delta times q times d. Okay, so if you want to put up the values of this one, mu will be equal to 0.41. What's the charge of one electron or one proton? It is 1.6 times 10 to the power of minus 19 coulomb. So the distance between them is given in the question. The distance or the radius is 0.926 angstrom, or we can write the 0.926 angstrom. Angstrom is 10 to the power of minus 10 meters. We know that the unit of dBi is in coulomb times meter. So we have coulomb and we have meter. Now we have to multiply them, and we will find that mu is equal to 6.07 times 10 to the power of minus 30 coulomb times meter. And as I have told you that we have to find the unit of this in dBi, so 1 dBi is equal to, so we can write 1 dBi was equal to 3.336 times 10 to the power of minus 30 coulomb times meter. We can cancel coulomb times meter, and if we simplify this, the remaining mu will be mu is equal to 1.82 dBi. This is the dipole moment for hydrogen fluoride molecule with the unit of dBi. That's how we can calculate the dipole moment of a molecule. But if you have pay some attention, there was only one bond, so it was a kind of bond moment or bond dipole moment. But if there will be more than one or one bonds in a molecule, then how can we calculate this? Then we have to find a simple way. We can use the vectors to find whether this molecule has a dipole moment or not. Okay, we don't need to talk about the quantity for right now. Now we are going to find whether a molecule has a dipole moment or not. So for a molecule, it is known as net dipole moment. Polarity or non-polarity of a molecule can be decided only by the net dipole moment of a molecule. We write it, the net dipole moment of it, this one can be written as mu net. The net dipole moment is calculated by the vector addition of all dipole moments which arise from the polar bonds. Okay, we have to add up all vectors that arise from the polar bond. All bond dipole moment must be added to find the net dipole moment of a molecule. And the next thing is, if a net dipole moment is non-zero, if it is not zero, if mu is not zero, in this case molecule is polar. Otherwise it is non-polar. If mu is equal to 0, it will be a non-polar molecule. Okay, and it will not have dipole moment. The next thing is the shape of a molecule and polarity of its bond determines the overall polarity of a molecule. A molecule that contains polar bonds might not have any overall polarity. Overall polarity means the dipole moment of the molecule. Maybe sometimes we see that all the bonds of a molecule are polar, but still molecule is not polar. The molecule itself is not polar. Only the bonds are polar, which means that it will not have any dipole moment. Let's have a look at some examples. First of all, we are going to study the dipole moment in diatomic molecules. The homoatomic diatomic molecules. Okay, we have oxygen and oxygen. Let me show the shape of this molecule. Oxygen to double bond oxygen. We know that the electronegative difference between them is 0. So in this case, mu will be is equal to 0. So there is no dipole moment. It is not a polar molecule. It is a non-polar molecule. Non-polar. Okay. So the next one is fluorine. For fluorine, we know that there is a single bond between fluorine and fluorine, and the electronegativity difference between them is 0 because 4 minus 4 makes 0. So in this case, its dipole moment will be equal to 0. It is also a non-polar molecule. What's the third one? Hydrogen. Hydrogen, one bond, single bond hydrogen. Okay. Over here, the electronegativity difference is also 0. electronegativity difference is also 0. So we can say that mu is equal to 0. It's also a non-polar molecule. Okay. Let's go for another example. So we have learned that homoatomic molecule, which have only 2 atoms, homoatomic diatomic molecule will be also a non-polar molecule. Let's see what about the heteroatomic molecules that are made up of only 2 atoms. About the HCl. Cl. Okay, there is a single bond between them. I have told you that it will have a partially positive charge, it will have a partially negative charge. So what do you think the vector will go from left to right? This shows the positive end, this shows the negative end. So we can say that mu of this one will not be 0. So it will be a polar molecule and it will have a dipole moment. Let's go for the next one. For hydrogen fluoride, again same thing, partial positive charge, partially negative charge, and the dipole moment is a vector quantity from positive to negative. It's again against the 0, so it's also a polar molecule. It will have a dipole moment. Let's go for the third one, hydrogen bromide. Hydrogen bromide is again from left to right because it has a positive partial charge, it's a negative partial charge. So dipole moment of this one will be also against the 0 or not 0. So it's also a polar molecule, which means that all of them will have a dipole moment. If a molecule is a heteroatomic molecule and the electronegativity difference between them is more than 0.5, then there will be dipole moment in the molecule. The next one is dipole moment in a polyatomic molecule. Okay, let's study the carbon dioxide first. We remember the carbon dioxide had a linear geometry, carbon in the middle and 2 oxygen at the sides with double bond. It's a linear geometry. It has 180-degree angle. Now, if we want to show the electronegativity difference between, we know that carbon is 2.5 and oxygen is 3.5. Electronegativity difference is 1, so it's very high. So we can say that this end is partially positive, this end is partially negative, this end is partially negative. Okay, so over here we can draw a vector something like this, and for this one we can draw a vector something like this. But we know that they both vector are of same quantity but in different direction, so they will cancel each other. So what do you think the dipole moment is? Over here dipole moment is 0. It's a non-polar molecule, it is not a polar molecule. Let's study for boron trifluoride. For boron trifluoride, we remember the shape was trigonal planar, okay, from the lesson of the molecular geometry. It's a trigonal planar geometry. And from boron to fluorine, we again know that the electronegative difference is very high. And if we write the vectors, it will be have a shape something like this. Okay, from boron to fluorine, from boron to fluorine, and from boron to fluorine. These 3 vectors cancel each other if you add them up. So again, in this case, in trigonal planar geometry, and if the all 3 atoms which are present at 3 sides are of same elements, in this case, the dipole moment of this will become 0. So it's a non-polar molecule. Let's study another example, and then we will finish the lesson. For this one is chloroform or trichloromethane. Now you can see this. In center there is carbon. Okay, so over here we have chlorine, and hydrogen. So we know that the electronegativity of hydrogen is less than carbon, but the bond between them was a non-polar bond. So we can overall the polarity between this bond is, we can say that it's a non-polar bond, but still there will be attraction of electron by the carbon. But when we look at these 3 bonds from here, the electronegativity difference is high. These bonds are polar bonds, so we can show the bond polarity something like this, bond dipole moment. So you can see that the overall the polarity of the molecule is going from up to down. So this end will have a partially positive charge and this end will have a partially negative charge. So it's a polar molecule. So we can say that if we add up these 3 vectors, we can say that it has a dipole moment from this part to the down, and we can say that its dipole moment or mu is not 0. It's a polar molecule. Let's go for the carbon tetrachloride, carbon in the middle and 4 chlorine at the sides, having a single bond, each one of them. In this case, students, if we want to write the one dipole moment of each one of them, the carbon, from carbon to chlorine, we can write something like this. We can write again this vector and then again and again. But you know that it's a tetrahedral molecule. So the attraction or the overall polarity of the molecule will become 0. Why? Because these all 4 bonds will cancel each other. We know that the bond is a polar bond, but the molecule is a non-polar molecule. So again, the dipole moment of this one will be 0. You can see only the presence of hydrogen change the case. So it's a polar molecule, it's a non-polar molecule. We are not talking about the polar or non-polar bonds. We are talking about the molecule. Let's look up at the water. What about the water? We remember that in water, oxygen was in the center and hydrogen are located at the sides with a bent geometry. We have studied this, okay? And there are 2 lone pairs upon the oxygen, 1 lone pair and second lone pair. And students, we know that the electronegativity difference between hydrogen and oxygen is quite high, is a kind of 1.4, because oxygen 3.5, hydrogen is 2.1. So electronegativity difference makes 1.4. In this case, if we draw the vector, it will become, it will be something like this: from hydrogen to oxygen, and again from hydrogen to oxygen. And what's the next advantage of the oxygen? It has also 2 lone pairs. So which means that the overall polarity of this oxygen molecule will be from hydrogen, and this end will be they will have partially positive charge, and this end will have partially negative charge. So what do you think the overall polarity of this one? It will have the polarity from this side to this side. Yes. So what do you think? What will the value of mu? The mu is equal to, is not equal to 0. Yes. So it's also a polar molecule, so it has a dipole moment. If the mu is not equal to 0, it will have a dipole moment. If mu is equal to 0, it won't have a dipole moment. Okay, students, hope you have learned what's the dipole moment and how to find the polarity of a molecule. Thank you for watching the video, and don't forget to subscribe our channel and give a thumbs up. See you next time. Bye bye.